Welcome to this video on modules. So in more complex programs, so when you are writing software, you are usually using many different code segments from other people in the form of modules or of packages. So this is going to improve the structure of large programs. If you don't need to program everything by yourself, you actually will end up with a way shorter program, and you can even have your own code segments, your own functions. You can also outsource in modules to improve the structure. You can use the same code that you put in these modules across multiple projects. So if you are a professional data scientist and you have your code that you are using over and over again in all these projects, you can write a module and then you can just use this model in all your software projects. And the most important thing, in my opinion, is you can share the code with others, and more importantly, other people are sharing the code with you. So the world's best libraries, for example, for data science, they are written down in Python and they are available for you, and they are available for you for free. So this is a great advantage, and Python is also very important in the field of data science, just due to the fact of its very fast nature and the idea that all the data scientists, they are meeting in the Python world and giving you all these modules. So let's create our own module, and we are just doing this in the slides. So modules are Python files that end with .py. In the Python Jupyter world, we are using I interactive Py and B interactive Python notebooks, but usually there is a Python file that is just .py. And we are opening such a file and we are writing down the following functions. Yeah, we learned about functions already. We learned about having dictionaries here. So actually what we are doing is we are in the first function getting a dictionary. We are adding something to that dictionary, and then we are returning the dictionary. Yeah, that's an in-place operation. We don't need to return it, but let's pretend we are doing it. And the other function is just printing all the uses here, right? So these are these two functions we put in that file that is called l8_module.py. And this is our module now. This is everything what you have to do to define a module. And in another file that is in the same folder, we are going to import that module. We just write import and then the file name. We don't need the ending .py here. And what we can do here is we are having a dictionary, an empty dictionary here detected by the curly brackets, and then we are simply going to call these functions. We need to have the module name or the file name before, and then we come up with all the functions that are in these modules. And very often you are using these functions from modules that you are importing, and you have never looked on these functions, you just know what they do. For example, the print command, that's also a function. In this case, we don't import a module, but it's also a function that you never look at. You're just using it, right? So again, we have this import keyword and then the module name. Then we can call the function by piping it with a dot. And this will lead then to the following output for this example. So let's talk about aliases, because they are usually used when working with modules. So if we are going to import that module, you don't want to write all the time l8_module. You can just write it short as mm. This is your alias, and then we write simply mm dot and then a method. So we can also import just one function of that module or multiple functions, and we can even then rename that function. And in this case, we simply import the add new user and we rename it shorter for just add, and then we can simply call the function with add and then the parentheses. So I just show you three important modules that we cover first in our data science course. So import numpy snp. The np is a very popular alias for the numpy module, and numpy is a very popular module for the whole data science world. There's also pandas, there's also matplotlib. for plotting data, pandas for analyzing data and working with large data sets. So let's open the Jupyter Notebook again, and here we are going to have a look on the module matplotlib. And this is how you import it. By the way, matplotlib is the package and pyplot is a sub-package or a sub-module, and we are going to rename it just with PLT, and this is how the whole world is doing it. This is the usual alias for it. And what PLT is able to do, it is able to plot some data. Let's have a quick example here. We are simply, can also write it like this. We are simply plotting let's say alias PLT. Sorry, I'm missing something here. Okay, this is doing the job. So we have just a straight line here that is actually plotted, and without looking on the function plot, that is something very complicated, we are very efficiently with just one line able to create a plot. There is also another library that is very heavily used by the community, and this is called NumPy, and this is the reason Python is fast. Python by nature is not a fast programming language, but using NumPy is enabling Python to do very fast calculations, like fast as C code, and we are going to use that here. We are defining a array that is actually just a list as we just saw it. And then we have a so-called array, and this array is going to be squared. And then we are going to plot the array. And now you have something that is actually just having a code like this. Yeah, when I'm going to have the S here, so we should see something that is having like this quadratic character. So you can see that with a few lines of code you were able to plot these kind of things, and this shows you how fast you can proceed when you know these libraries well. Usually data scientists have a handful of libraries like pandas, NumPy, matplotlib, then there's something like sklearn or PyTorch for neural networks. And if you are mastering these libraries, you are very good to go for challenges in data science.